Hi, hello, how are you students? Welcome back to my channel Maths for All. This is Sudhakar Reddy. As I said in the last session, so we are going to discuss about the next topic which will be useful for JEE main. So the next topic is definite integration. Definite integration. So this is a very important chapter in the JEE main point of view and also the in JEE advanced point of view. This is a very important topic. There are a lot of modulation, there are a lot of concepts, there are a lot of models in this definite integration. So let us discuss one by one. So the first question is like this. Once again, I'm telling these are all the previous JEE mains questions. These are all the previous JEE mains questions. The first question is like this. The value of alpha for which the question is like this. 4 alpha into integral minus 1 to 2 e power minus alpha into mod x dx is equals to 5. This is the question he has given. The value of alpha for which 4 alpha into integral minus 1 to 2 e power minus alpha into mod x dx is equals to 5. That means this problem is based on modulus. So let us discuss about modulus property. So first of all, whenever modulus problems are given in the definite integration, so first thing is how to remove the modulus. So we have the property for modulus function definition. Mod x is equals to plus x if x greater than or equals to 0, minus x if x less than 0. Of course, you can write equality symbol in the first one or the second one. It's not a problem. So now, so 4 alpha into, here the observe the limits minus 1 to 2. In that interval, there are negative values and also the positive values. Okay, so whenever the value of x is negative, modulus of x becomes minus x. Whenever the value of x is positive, modulus of x becomes the plus x. So, in between minus 1 and 2, there is 0. Up to minus 1 to 0, all the values are negative. From 0 to 2, all the values are positive. So that's why we are going to split the modulus function. How do you split the modulus function? See, it's very important concept. So minus 1 to 0. From minus 1 to 0, in between minus 1 to 0, all the values are negative. So when x less than 0, modulus of x becomes the minus x. So this modulus of x becomes the minus x, minus into minus plus. So this is e to the power of alpha x dx. Plus integral 0 to 2. Again, this is the property integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x plus splitting of definite integral. Right. So minus 1 to 2 can be splitting as minus 1 to 0 and 0 to 2. So in between 0 to 2, all the values are positive. No? So when x greater than 0, modulus of x becomes the plus x. So modulus of x becomes the plus x. So this is e power minus alpha x dx. So now there is no modulus in the given problem. Now we can integrate very easily. So like this, we have to evaluate the modulus symbol first of all. That is a process. Achha. So that should be equal to 5 as given. This should be equal to 5. So just integrate. It's a simple integration. This is 4 alpha into the integration for e power alpha x is e power alpha x by alpha because the x coefficient is alpha. The integration for e power alpha is e power alpha x by alpha. So you can write 1 by alpha is a constant. You can write outside of the integration. So e power alpha x by alpha. So e power alpha x. The limits are minus 1 to 0. So now the integration for e power minus alpha x is e power minus alpha x by minus 1 by minus alpha. So this is minus 1 by alpha plus becomes minus plus minus no. So e power minus alpha x. The limits are 0 to 2. That should be equal to 5. So this is here, take 1 by alpha as a common term. So 4 alpha into 1 by alpha gets cancelled. So 4 times of, just apply the upper limit. First you have to apply the upper limit now. So e power, where we have to write in the upper limit? So here the variable of integration is x. The variable of integration is x now. So we have to substitute the limits in the variable of integration. So here the variable of integration is x. That means we have to substitute the limits in place of x. Just substitute. So e power alpha into 0. So e power 0, 1 minus upper limit minus lower limit. So e power alpha into minus 1. So e power minus alpha. E power minus alpha. Minus e power minus 2 alpha. If you apply the upper limit, minus e power minus alpha into 0, e power 0, 1. That should be equal to 5. That should be equal to 5. Achha. So this is 4 times of, so write this plus e minus e power minus 2 alpha first. After that minus e power minus alpha plus 1 and minus into minus plus 2 is equals to 5. Is equals to 5. So let us take e power minus alpha as a for some time. E power minus alpha is equals to a. Let us take e power minus alpha is equals to a. So this is 4 into, this is e power minus alpha whole square. It is minus a square minus a plus 2 is equals to 5. Minus a square minus a plus 2 is equals to 5. Isn't it? So now we get a quadratic equation in terms of a. Solve it. Automatically we will get the value of alpha. So let us remember this condition. 4 into minus a square minus a plus 2 equals to 5. So 4 into, so just open the bracket. So minus 4a square minus 4a minus 4a. So plus 8, take that plus 5 to this side. So plus 8 plus 5, sorry, minus 5 plus 3 equals to 0. Plus 3 equals to 0. So multiply with the minus and 4a square plus 4a minus 3 is equals to 0. Just simple factorization. 4a square plus 6a minus 2a minus 3 is equals to 0. So take 4a as a common term. So not 4a, it is 2a. So it is 2a plus 3 minus 1 into 2a plus 3 is equals to 0. So 2a is equals to minus 1. So 2a is equal to plus 1. So a is equals to 1 by 2. So 2a is equals to minus 3. So a is equals to minus 3 by 2. Minus 3. But what is a? E power minus alpha. So therefore, e power minus alpha is equals to 1 by 2. E power minus alpha is equals to 1 by 2. From that, how do you find out the value of alpha? So apply the logarithm. So minus alpha is equals to log of 1 by 2. ln of 1 by 2, I think. Minus alpha is equal to, if you apply the logarithm with base e, so minus alpha into ln e is equals to log of ln of 1 by 2. So minus alpha is equals to minus of ln 2. So alpha is equals to ln 2. Alpha is equals to ln 2. So if we take a is equals to minus 3 by 2, a is equal to plus 3 by, sorry, minus 3 by 2, we will get one more alpha. So here, how many values are there for alpha? 2 values. He may give one value in the option because it's a single answer question. If it is a multiple answer questions, he may give 2 values. So this is the way to do this question. So when our modulus symbol is there, first of all, let us check how do we remove the modulus by applying the modulus property. After removing the modulus, then only we can approach the problem. Then only we can integrate the problem. Clear? Right. This is one model, modulus model, problem based on modulus. Remember, this is the previous question. So lengthy calculation is there here. See the next question. The next question is like this. Integral 0 to pi by 3. This is the next model. Integral 0 to pi by 3. Tan theta whole by square root of 2k secant theta. 2k secant theta. D theta is equals to 1 minus 1 by root 2. Integral 0 to pi by 3. Tan theta by square root of 2k secant theta d theta equal to 1 minus 1 by root 2. 1 minus 1 by root 2 raised. Right? Then k is equals to. Then k is equals to. Right. So how do we approach this question? Let us see. Yeah, square root of 2k. Square root of 2k secant theta can be written as square root of 2k into square root of secant theta. Square root of a into b, square root of a into square root of b. Achha. So this square root of 2k is a constant, you can write outside of the integration. First write that constant outside of the integration, square root of 2k into integral 0 to pi by 3. Integral 0 to pi by 3. Achha. Right, tan theta can be written as sin theta by cos theta. Sin theta by cos theta. This is 1 by square root of cos theta, right? Why? Because secant theta is nothing but 1 by cos theta. Secant theta is nothing but 1 by cos theta. Achha. Right. Okay. So this root of secant theta, this root of cos theta cancels in cos theta root times. Okay. So now the given question is like this: 1 by square root of 2k into integral 0 to pi by 3 sin theta by root of cos theta d theta is equals to 1 minus 1 by root 2 is equals to 1 minus 1 by root 2. Right? Right. Achha. So do you know the derivative of cos theta? What is the derivative of cos theta? See, it's a very simple question. What is the derivative of cos theta? The derivative of cos theta, cos theta derivative minus sin theta. Minus sin theta or plus sin theta. The integration for cos theta is sin theta. Don't be confused. The integration for cos theta is sin theta, but the derivative of cos theta is minus sin theta. Oh, so the minus is not there now. Just balance it. So minus 1 by square root of 2k into integral 0 to pi by 3 minus sin theta by square root of cos theta d theta is equals to 1 minus 1 by root 2 is equals to 1 minus 1 by root 2. So why you multiplied with minus r? Let me explain. So what is the derivative of cos theta? What is the derivative of cos theta? Minus sin theta. But the function is under the root 2 now. The function is under root. So there is a formula. So that formula you should remember: integral f dash of x by formula is root of f of x. Integral f dash of x by root of f of x. The formula for that is integral f dash of x by root of f of x dx formula 2 root of f of x. Integral f dash of x by f of x dx formula 2 root of f of x. So clearly it is of the form integral f dash of x by what is the function under the root? Cos theta. The derivative of cos theta is minus sin theta. Clearly this integral is of the form integral f dash of x by f of x dx. The formula is 2 root f of x. Okay. So minus 1 by root 2 into root k into the integration for this one is 2 root cos theta. 2 root cos theta. Limits 0 to pi by 3. Limits 0 to pi by 3. Achha. So that should be equal to 1 minus 1 by root 2. 1 minus 1 by root 2. Achha. Clear. Okay. So this root 2 cancels into this root 2 times. Root 2 times. So now the LHS becomes minus root 2 by root k. Minus root 2 by root k. Just apply the remains. What is the value of cos pi by 3? Cos pi by 3 is nothing but 1 by 2. So it is under root now, it is 1 by root 2. It is 1 by root 2. This is the value by applying the upper limit. Cos 0, 1. So that is the value by applying the lower limit. By applying the lower limit. That is LHS. So now what is RHS? 1 minus 1 by root 2, take minus common. So minus of 1 by root 2 minus. Minus of 1 by root 2 minus 1. Achha. So here 1 by root 2 minus 1, 1 by root 2 minus 1, of course minus 1 minus gets cancels. So finally root 2 by root k is equals to 1. Root 2 by root k is equals to 1. So that root k is equals to root 2. The final answer for this k is 2. That's the k value. That is the k value. Okay. So definite integration is easy, but somewhat tedious calculations are there. So calculation means addition, subtraction, multiplication, division. Don't you know these 4 calculations? From childhood you are learning addition, subtraction, multiplication. If you take any calculation, these 4 are L1. That's it. Addition, subtraction, multiplication, division. That's it. If you know these 4 calculations perfectly, you can do. Right? Okay. So this is the easy question. Okay. So let us discuss the next model, indefinite integration. The next question is like this. So very, very important model. Integral minus pi by 2 to plus pi by 2. integral minus pi by 2 to plus pi by 2 dx by step of x plus step of sin x plus 4. Integral minus pi by 2 to plus pi by 2 dx by step of x plus step of sin x plus 4 dx. This is very important model. Very important model. Integral minus pi by 2 to plus pi by 2 dx by step of x plus step of sin x plus step of 4. Okay. So the first thing you have to observe here is the limits. Whenever the limits are of the form integral minus a to plus a. Whenever the limits are of the form integral minus a to plus a, so first thing you have to check is whether the given function is even or odd. Whether the given function is even or odd. The property here is integral minus a to plus a f of x dx is equals to twice integral 0 to a f of x dx or 0. So integral minus a to f of x dx is equal to twice integral 0 to f of x dx if f of x is even. If f of x is even, in this case the function should be even, in this case the function should be odd. Sir, what is even function, sir? What is odd function? When we say that the function f of x is even, sir, when we say that the function f of x is odd, sir. So even function means a function f of x is said to be even if f of minus x is equal to plus f of x. F of minus x is equal to plus f of x, then the function is said to be even function. If f of minus x is equal to, minus f of x, then the function is said to be odd function. This is the definition of even function and this is the definition of odd function, and this is the property. Whenever the limits are in the form of minus a to plus a, you should check whether the given function is either even or odd. If neither the given function is neither even nor odd, you have no need to apply this property. Okay, so let us check. So this is the function f of x is 1 by square step x plus step of sin x plus 4. Okay, so write minus x plus in the place of x, step of minus x, there is no property for step of minus x. Step of minus sin x, there is no property. Of course, step of minus x is, we have a property, step of minus x is equal to, minus 1 minus step x, minus 1 minus step x, if x is not an integer. If x is not an integer, how do you say that if x is not an integer here? Can we confirm here x is not an integer? We can't confirm. So that's why step of minus x is equal to minus 1 minus x, here we can't write. Okay, so that means here the given function is neither even nor odd, so no need to apply the property. Achha. So what is the value of, what definition of step x? Step x is equals to n when n less than or equal to x less than n plus 1. This is a simple definition of step x. The value of step x is equals to n when the value of x is lies in between two consecutive integers, n less than or equal to x less than n plus 1. Okay, right. Here step x is there and minus step of sin x is also there. Here step x is there and step of sin x is also there. Remember, there is no integration and there is no derivative for step function. Remember, here the very important thing is there is no integration and there is no derivative for step function. So what we have to do, sir? So we have to find out the particular integral in that particular interval. You have to find out that value. We have to find out that particular value in that particular interval. Okay, here minus pi means, pi means 3.14, pi by 2 means 1.57. Okay, so here for your convenience I am going to write like this. The limits are in the form of lower limit is minus 1.7, upper limit is plus 1.57, isn't it? Pi by 2, pi means 3.14, not exactly approximately. The value of pi by 2 is minus pi by 2 is minus 1.57, plus pi by 2 is plus 1.57. Achha. So is there any integers between minus 1.57 to plus 1.57? Why not? So minus 1 is there, 0 is there, 1 is there. In between minus pi by 2 to plus pi by 2, that means in between minus 1.57 to plus 1.57, there are integers minus 1, 0, plus 1. Of course, minus 1.57 is nothing but minus pi by 2. So, that integral can be split as like this, integral minus pi by 2, that is nothing but minus 1.57 to minus 1. To minus 1. So that means here the value of x lies in between, minus 1.57 to minus 1. Here the value of x lies in between minus 1.57 to minus 1. Minus 1.57 to minus 1. Acha. So minus 1.57 to, can you please tell me some values which lies in between minus 1.57 to minus 1? So that is minus 1.4, minus 1.2, minus 1.3, like this. So what is the value of step of minus 1.2? Step of minus 1.3, step of minus 1.4. So the value of step of minus 1.2, the value of step of minus 1.3, like this. So for all these values, the value of step is minus 2. Minus 2. That means in this particular interval, the value of step of x is minus 2. So dx by the value of step of x is minus 2. Achha. Okay, right. So now how do you find out modulus of step of sin x? Step of sin x in between minus pi minus, this is minus pi by 2, no? Minus pi by 2 to minus 1. Right. So whenever minus pi limits are given, minus pi by 2 to plus pi by 2, 0 is there. So minus pi by 2 to 0. Minus pi by 2 to 0, which quadrant? Minus pi by 2 to 0, which quadrant? Can you please tell me? Minus pi by 2 to 0 is fourth quadrant. 0 to pi by 2 positive direction, 0 to minus pi by 2 negative direction. 0 to pi by 2 first quadrant, 0 to minus pi by 2 fourth quadrant. That means minus pi by 2 to 0 belongs to fourth quadrant. In fourth quadrant, sign negative or positive? In fourth quadrant, sign negative or positive? Negative. Negative. That means from minus pi by 2 to 0, the value of sin x is negative. But of course, as you all know, the value of sin x lies in between minus 1 to 0. The value of sin x lies in between minus 1 to 0. So that means from minus pi by 2 to 0, the value of sin x is lies in between minus 1 to 0. So can you please tell me some values which lies in between minus 1 to 0? So minus 1 to 0, the values are like this, minus 0.9, minus 0.1, minus 0.3, like this. So if you apply the step for these type of values, you will get minus 1. So from minus pi by 2 to 0, from minus pi by 2 to 0, so the value of step of sin x is minus 1. The value of step of sin x is minus 1 from minus pi by 2 to 0. So that means in minus 1.27 to minus 1 and minus 1 to 0. In these two intervals, the value of step of sin x is minus 1. There is no doubt at all. So from minus 2 to minus 1, the value of step of sin x is minus 1 plus 4. That is as usual, right? After that, plus the next interval is minus 1 to 0, minus 1 to 0. Minus 1 to 0. So can you please tell me some values which lies in between minus 1 to 0? So the values which lies in between minus 1 to 0 are in the formula like this, minus 0.1, minus 0.2, minus 0.3, like this. If you apply the step for that, step of minus 0.1, step of minus 0.2, step of minus 0.3, if you apply step for that particular values, the value of step x is minus 1. So dx by minus 1. Just now I said that minus pi by 2 to 0, the value of step of sin x is minus 1. So the minus 1 plus 4 plus after that integral 0 to 1. Integral 0 to 1. Can you please tell me some values which lies in between 0 to 1? 0.1, 0.2, 0.3, like this. If you apply step for that particular value, step of 0.1, 0, step of 0.2, 0, step of 0.3, 0. So in this particular interval, the value of step x is 0. The value of step x is 0. So now from 0 to 1, that means whenever we cross the 0, so we are going to enter into the first quadrant. In first quadrant, sign is positive. In first quadrant, sign is positive. And also the value of sign is lies in between 0 to 1. The value of sign is lies in between 0 to 1. So 0.1, 0.2, 0.3, like this. So for that particular values, if you apply the step, the value is 0 again. So 0 plus 4 plus finally integral 1 to 1.57 is nothing but pi by 2. Integral 1 to 1.57 is nothing but pi by 2. So 1 to 1.57. Can you please tell me some values which lies in between 1 to 1.7, 1.1, 1.2, 1.3. If you apply the step for that particular values, that is 1 again. So that's dx by 1 plus. So from 1 to pi by 2, it is again first quadrant. In first quadrant, the value of sin is positive. The value of sin x is lies in between 0 to 1. So this is again 0. This is again 0 plus 4 is as usual. So whenever step problems are given like that, you have to write the particular integral value of that step. There is no integration, there is no derivative for steps. So now the question is like this, integral minus pi by 2 to minus 1. Integral minus pi by 2 to minus is minus 3 plus 4 plus 1. This is dx. Plus integral minus 1 to 0. This is minus 1 to 0, it is dx by 2. So dx by 2 plus integral 0 to 1, this is dx by 4, dx by 4 plus integral 1 to pi by 2, integral 1 to pi by 2 dx by 5, dx by 5, just integrate it. So integral dx means x, upper limit minus 1, lower limit minus of minus pi by 2, so the minus 1 plus pi by 2, minus 1 plus pi by 2, here 1 by 2 into integral dx x, upper limit 0, lower limit minus of minus 1 plus 0 plus 1, plus 1 by 4 into upper limit 1, lower limit 0, because integral dx x plus 1 by 5 into plus 1 by 5 into upper limit pi by 2, lower limit minus 1. Just simplify it. The minus 1 plus pi by 2, this is plus 1 by 2, that is plus 1 by 4 plus pi by 10 minus 1 by 5. Just calculate it. If we calculate, automatically we will get the answer. So like this, we can evaluate the questions. Like this, we can evaluate the questions in definite integration. Okay, so in the next question, we will discuss some more important questions in the same definite integration, because there are a lot of models in the definite integration. So for definite integration, I'll take 2 sessions. In the next session, we will discuss some more important models, okay, in the next session. Okay, so please watch these videos, please utilize these concepts and try to get good marks in JEE Main 2020. Right, thank you very much.